Good evening. Honors Algebra 2, Chapter 2, Section 3, Quick Graphs. And then we're talking about quick linear graphs. Concepts we should know is how to graph use by making a table. We actually talked about that yesterday. Then using slope-intercept form and then standard form. So some shortcuts to graphing. Slope-intercept form, it's one of those equations that students graduate high school on just having memorized. We should all know this. Y equals mx plus b. And this b is the y-intercept, also known as like the starting value. People call it the starting value, because the y-intercept, the x value is actually equal to 0. So when you put 0 in for x, you're finding the y-intercept or the b value. So m is the slope, and we talked about slope yesterday. It's rise over run. We found by doing y2 minus y1 over x2 minus x1. We look at the graph, we're using a rise over run mostly. So x, y are just points that make the equation true. So you plug it back into the equation. X and y would be solutions to that equation. So to graph, we can put the equation in slope-intercept form, which we need to solve for y or isolate y, and then we can simplify it, and then that puts it into slope-intercept form. And then to graph, we want to plot the y-intercept first. Always plot that point, and then you're going to use the slope to plot more points and multiple points, and then just connect the points. Those are the steps we've done in the past and previous years, hopefully, to graph. So here we go. Let's put this into slope-intercept form first, and again, we know it's not because y is not isolate, it's not solved by itself. So I want to first get y by itself. You can do that many ways. I would actually add 5y to both sides first, so that I'm actually putting it on the right-hand side. Then I would subtract 25. And then the last step is to divide by 5. When we divide by 5, we're dividing the entire left side by 5. We're dividing the right side by 5 to isolate the y. So here y equals, and then we're dividing both terms by 5. So we have 3 divided by 5 right here, and we have 25 or negative 25 divided by 5 there. So if you write that as a fraction, 3/5 x minus 5. 25 over 5. So then here's our equation. In this we should call what our b value is, which is actually negative 5, our y-intercept, and then our m value is 3/5. So pull that out of your equation. We can use the information in the graph. To graph it, we first plot the y-intercept. So here's negative 5 going by ones, and then our slope, this is our rise over run. Rise over run. So rise is our numerator, so we're going up 3, and our run is left and right. Because they're positive, we're going up and right. So up 3, then right 5. And those are 2 points. We can use those 2 points then to graph the line. And I will use the tools to draw my line for me. So in the equation y equals mx plus b, the equation that represents slope is our m value, or the variable that represents slope is our m value. The variable that's the y-intercept is b. Make sure you know those by variable by name. Some equations are not in slope-intercept form, like this equation, just like the one we just solved as well. This can be changed into slope-intercept form, but there's actually another shortcut. These equations are in what's called standard form. Standard form is right here, ax plus by equals c, where a, b, and c are just constants. Again, constants are our values, numbers. And then x and y would be our variables within the equation. All equations can be written in standard form. So that's a big difference between slope-intercept form. Not all equations can be written in slope-intercept form. They can be written in standard form. So are these equations in standard form? So for this equation here, no, this one right here is not in standard form. It's actually in slope-intercept form. To put it in standard, I could subtract 3x to both sides to get x and y on the same side, and now that is in standard form. And our a value is negative 3, our b value would be 1, our c value is negative 5. The second equation here, this one is in standard form, Well, nice little trick here. We could divide everything on this by 2, divide both sides by 2 to make it a little bit smaller values, coefficients. And then we can roll with that equation. Third equation, this is not simplified. I would need to simplify it first. And then I could actually divide this both sides by 3 to write another equivalent equation and make it the numbers a little smaller. And the last one again is not in standard form. I can subtract 2y. Write the x's first, then minus the 2y equals -6. And so there's another example of standard form. To graph standard form, we use a shortcut. We just find the intercepts. That's what you do to graph standard form. And for intercepts, let's review. A y-intercept has an x value of 0. So to find the y-intercept, we just let x equal 0. And every x-intercept has a y value of 0. So to find the x-intercept, we let the y equal 0. So if you recall yesterday when we were making a table, if you put 0 in for x and then 0 in for y to find 2 points, you're finding the y-intercept and the x-intercept. So if you plot those 2 points and connect them, you'll find the graph, or you'll be able to graph it. Knowing it's a line, because it's in standard form, 2 points is sufficient to graph it. So example here, we have our a value is 3, our b value is 2, our c value is 6. To find our x and y intercepts, to find x, we let y equal 0. So for the x-intercept, let's let y equal 0. So then we plug in 0 for y. That always gives us a term of 0 there. So then we find our x value is 2. And again, this is our x-intercept. So the point we just found was 2, 0, because we let y equal 0. If we do that same thing again, but we want to find the y-intercept, we can let x equal 0, and then plug and chug. So 3 times 0 is 0, so we have 2y equals 6, and then y is 3. So we have the point 0, 3. Now it's a coincidence that the 2 and 3, the x-intercept and y-intercept, are the same in the problem. That's not usually the case, but it is here. And so let's plot those points. We have 2, 0, and 0, 3. And we can use those 2 points then to put arrows on it. The 2 examples here, we can graph these equations using the shortcut, and we can actually become a little faster with it if you see the process. To find the y-intercept, we are letting x be 0. And so when we plug 0 in for x, what occurs? Well, 4 times 0 is 0, so that term is gone. So all we're left with is 2y equals 12. So then if we actually isolate that, we find that the y-intercept is going to be y equals 6 when x equals 0. So we let x equal 0. So that ends up being the point 0, 6. Now we can do the same thing, but we can actually find the x-intercept. To find the x-intercept, we're going to let our y value be 0. 2 times 0 is 0. So we're left with 4x equals 12. So divided by 4, I find that x is 3. And again, we let y equal 0 there. So it's the point 3, 0. So then we can plot those 2 points on the graph and then connect them to graph our line. So 3, 0 and 0, 6. If I go by 2's, I'm going by 1's on the x-axis. You can choose your increments, and I can draw my line. There would be the graph for that equation. Now, if you really see how quick this graphing can be, you should see how it's this constant c divided by the coefficients to find the y-intercept and divide by this coefficient. So you can similarly do it with this equation here. I'm going to have you graph this. So this is kind of a mini problem for you to try, a video problem, so you can come in the day tomorrow and have that turned in to test to see how you do in this skill. Graphing these, 0 times x is 0, so really that term's gone, so we just have 2y equals 8. Now this is a little different. We don't have an x in it, so we have y equals 4. Well, y equals 4 is right here, but there's more than that point. This point is also y equals 4, and this is 4, and this is 4. All of these points have y values of 4. The x value changes, but the y value is 4. And it doesn't matter what our x is here because we're going to multiply it by 0 in the problem. We'll multiply that by 0 so it becomes 0. So we don't care what the x value is. Our y value is 4 is anything on this horizontal line. So anytime you have an equation that has the y, only a y in it, you're dealing with a horizontal line. And these are the equations that are specific to the standard form. You can't put into slope-intercept form because there's no x value to use. The next one, we now have 0 for the coefficient for y, so it's going to be multiplied to get rid of that term. So you just end up with 3x equals 9. So x is 3. So for this one, our x value is 3 is right here, and anything on the vertical line, so assume you have vertical line. Anything has x and only an x, no y, that's going to be a vertical. So these are two special cases. They're ones that can be written in standard form but not slope-intercept form. So looking at this, 1, 2, 3, up 3, my y value as I move along this has not changed. Y is always 3, so the equation has y is 3. For this one, go left 3, negative 3, and my x value stays constant. So I can say my x value is negative 3. So like another confusing thing are these axes. The x-axis here, we call it the x-axis, but the equation of that is actually y equals 0. So they're kind of backwards, opposite what you think. For these equations, how would we graph this? This is in standard form, so I would find the x and y intercept. X and y intercept is the method I would use. And to find it quickly, I just know the y intercept is 5/2. And I know the x intercept is 5/4. And all I'm doing is I'm taking, if I'm finding the y intercept, I'm taking the constant divided by the coefficient to y. That's the y-intercept. Or the constant divided by the coefficient x to find the x-intercept. And that'll always work because the other term will not be there when you're finding the intercept. You're letting it have a value of 0. The variable will be 0. For this one, it's going to be a vertical line. It's a special case. Solve for x, draw the vertical line. Here, this one is slope-intercept form, so I'm going to use m is -4, -4, 1. And b value is -6. Make sure we use our signs. And this as well is slope-intercept form. So we have an m value of -1/5 and a b value of 1/3. So that's it. We have you should be able to graph by making a table. That was more what we talked about yesterday, but plugging and chugging. You should be able to use slope-intercept form, the y-intercept and slope. And standard form, finding x and y intercepts quickly. These should be very quick graphs. Have a good night. See you tomorrow. Post any questions on YouTube.